Today, the 2020 Solar Module Reliability Scorecard, Bankability Testing for the Solar Industry. Welcome to SolarWorks for Illinois. I'm Tim Montague, your host. Today, my guest is Tristan Erion-Lorico, Head of PV Module Business at PV Evolution Labs, known in the industry as PVEL or PVEL. Welcome to the show, Tristan.
Thanks, Tim. Happy to be here.
So excited to dive into module quality and reliability. I like to say that solar is very mature technology. It is, it has been around for 70 years now. And so these panels really are tried and true in so many ways, and the failure rates are generally very low. But all modules are not created equal, and PVEL has created this very robust testing and reliability program, which we're going to dive into today. But why don't we start off our listeners, Tristan, and tell us a little bit about yourself and how you came to PVEL.
Sure. Thanks, Tim. So I've been in the solar electrical industry for about 15 years. I started in electrical manufacturing and then moved into solar manufacturing, really wanted to get into renewables. And through my manufacturing experience, was the product and quality manager at Silfab Solar for a number of years, where I was responsible for their new products. And of course, ensuring the reliability of those products fell onto my desk, and worked with PV Evolution Labs at that time for their third-party reliability testing. After I left Silfab, I worked in the downstream doing O&M for some sites throughout the Americas and also into Asia, and also helping with procurement at two different independent power producers, and really learned about the process of procuring products and why reliability is so important. So I had seen both the upstream side from the manufacturer side of things and the downstream side from the purchasing side of things. And when this opportunity opened at PVEL, it was perfect for me, and that's how I came on board.
And give us a high level, what is the Module Reliability Scorecard?
So it's a publicly facing document that PVEL puts out every year. We just released our 6th edition in 2020, a couple weeks ago. And it's really to show the industry what are some of the field failures happening out there, what are the in-lab failures, how do those two things connect, and show why we're doing the testing we're doing, how it benefits the industry, and of course who the top performing models are and manufacturers associated with those models.
Indeed. So who are your primary target audiences?
So we're the lab for the downstream. So we've been around since 2010, and we were really started to provide the downstream with empirical data to replace assumptions that are made on reliability and on performance. So our main target audience is the downstream module purchasers. Now, at the same time, we want to educate the market. We make the scorecard accessible. We have lots of non-technical people read it to try to make the language as accessible as possible, so that bankers who are not deeply familiar with module technology but are putting a lot of money on the line, they can read it and understand why our testing is important, and they can get the key takeaways from the report. I would say secondary, it's also for the manufacturers so that they can benchmark their performance to what we're seeing in the industry.
So true. And, I see a tremendous need for both sides of this coin, and just a general better awareness in the industry at large for module quality and reliability. There have been quality and reliability problems. I'm going to be doing a podcast on solar fires for
Right. Yeah.
example. And so while solar is largely set it and forget it, and if you're doing proper annual maintenance, you really don't have to worry too much about your solar array, but there's nothing like that third party verification of quality and reliability. So we're going to get into some of the guts of what that's about and what all you guys test for.
Excellent.
How did this scorecard come about anyway?
So we started our main product qualification program, or PQP, back in 2012, and that's the testing program that goes behind the scorecard, and is really the data for the scorecard is pulled from the PQP. So that was started in 2012, and we were getting all of this excellent data that we wanted to share with the broader industry. So we had our what we call downstream partners, who are companies that have signed an NDA and signed up to access the PQP reports. There's no charge for that for the downstream. And independent engineers are signed up, and financiers, developers, asset owners, O&M companies, et cetera, et cetera. So they were accessing all of this great data on module reliability, but we realized that we needed to have something that was more publicly facing, so that we could reach more people and get them to understand that empirical data is available, A, and B, that there are manufacturers that are outpacing their competition in reliability test results. So the scorecard was launched in 2014, and it's become an annual publication since then.
Wonderful. So I understand the primary audience is the downstream. That's installers like ourselves, developers, asset owners, anybody who has a long-term interest in solar project reliability and performance. But how do manufacturers engage in the program?
So typically how it works is the downstream, as part of their approved vendor list requirements, or as part of their request for proposal requirements, they require PVEL's PQP testing, and manufacturers hear that message from the downstream. It's one thing for me as the head of module business to start cold calling manufacturers and saying, hey, you should sign up for our testing program, which sometimes works. But frankly, it's another thing for the downstream to say, I need this data. I need this data to understand your module performance and your module reliability better. And I'm not going to purchase modules without this data. So please contact PVEL and get signed up for the product qualification program. And then I'll have the data I need to feel comfortable making purchases for your modules that you're trying to sell me. So that's really what instigates it. And then the manufacturers will contact me specifically, and I'll work with them to understand their bill of materials, which are all of the different materials that go into their modules. So the cells, the glass, the anti-reflective coating, right down to, what connectors they're using, what junction box potents they're using, all of the different materials in the module. And I'll determine the test program required for those various bill of materials combinations. And from there, it turns into a proposal once we understand how much the bill of materials changes. And then they sign it. And the next step is we go to the factory and we actually do a factory witness and watch the samples being made that get shipped to PVEL for testing. So we have a third party that goes in and verifies what potent's being used, verifies the encapsulant, the solar cells, etc. And that becomes the first report of the PQP. We call it the witness report, and it lists that bill of materials. So that's kind of the first few steps in the PQP. Then the samples get shipped to us, and we start testing them. They're sealed in a tamper-proof tape on the pallet, and each module is signed. So when we do our our incoming inspection of these modules arriving at the lab, we make sure that they haven't been tampered with, so that, you know, someone hasn't replaced the samples with a higher performing backsheet, if you will, while calling it a cheaper backsheet, so to speak.
Yeah, it kind of brings up the evolution of technology, right? Because while it is mature technology, it's also a fast evolving technology. The solar cells themselves are evolving. We now see half cut and third cut cells coming on the market in really high quantities.
Yeah.
And of course, energy density is going up. The backsheet technology, glass on glass, bifacial modules. There's a lot of moving parts. How do you guys keep up with the industry? Is it just a matter of whoever engages, then you're staying on top of their technology, or how do you keep up with evolution of the technology?
Yeah, certainly, you know, it's my job when I see a manufacturer releases a new module type. I'm getting on the phone, I'm hitting them up, typically on WeChat, because a lot of them are in China, and that's their preferred communication method. But I'm contacting them and saying, hey, we got to get these modules in the lab, that the downstream's going to want to see the data on these modules. But again, the real motivator for them is when module purchasers say, hey, this new technology is great, I like what you're doing here, but I can't purchase it without the empirical PVEL data. And you know, they've in some cases learned the hard way when they don't take that firm stance, and they purchase something that experiences more failures than what they anticipated in their financial models. So, you know, it's a combination of us being proactive and encouraging the manufacturers to test, and also the downstream doing the same. But I agree, the number of bills of materials, and not just bills of materials, but module types, cell sizes. You know, we had a project with a company where they had their 156.75 millimeter cell, then they went to 158.75 millimeter, then they went to half cut at that 158. Now they're asking me for proposals for 166 millimeter and 180 millimeter, and that's all in the last 6 months. Like, they're, you know, it's such a moving target. They don't even know what they're going to be selling in a year. And I doubt they've even started producing with some of those cell sizes, because they have to change their whole manufacturing lines over. So they don't even understand the reliability of these new products. But there's such a watt peaks arms race, as I like to call it, that if now you're selling a 380 watt module, which a few years ago would have been phenomenal, now it's like 380 watts. I want to buy 500 watt plus. Like, what are you doing here? So, you know, everyone's just racing to have the latest and greatest, and they need data to support it.
So true about the module size. And after you and I had spoken last week, I did a little inquiry with one of the major manufacturers, and you know, they're coming out with 450 watt modules in 2021, and they're over 7 feet long. So the physical dimensions are getting bigger as well. So at a very high level, though, what is the testing involved? What are you guys doing with these modules that you're testing?
Yeah, so we have a number of tests. A lot of them are based on climate chamber tests, things such as thermal cycling, where you're going from minus 40 degrees Celsius up to plus 85 degrees Celsius. And that happens over a few hour period. And we do that 600 times, from minus 45 up to 80, down to minus 45. The certification standard for that is 200 cycles. We go to 600 cycles. There's another test, damp heat, where it's 85 degrees at 85% humidity. We do it for 2,000 hours. Certification is only 1,000 hours. And as we've shown in the scorecard, you know, there's modules that perform great at 1,000 hours, but then kind of fall off a cliff after 2,000 hours. There's a mechanical stress sequence where we're providing mechanical pressure on the module and then putting it through climate chamber tests after to see if there's cell cracking, and if that cell cracking, it leads to eventual power loss. Lots of other failure modes we're looking at as well, backsheet cracks, potential induced degradation. I believe there's 9 different tests. And then on the performance side, included in those 9 is looking at how the module performs at different temperatures, different irradiances, and different sun angles to really have good data go into your energy model. So you're not just making assumptions, you've got lab-based data to show how these modules perform.
Cool. And the report card itself, or the scorecard, sorry, is pretty much an executive summary, right? There's a whole bunch of stuff behind that. Tell us about that.
Yeah. So the scorecard really culminates the previous 18 months of results into this publicly available document, and we name the top performers for the various tests that we publish in the scorecard. But for each of those, names in the scorecard, there's multiple test reports, PQP test reports that show specific performance for that model type, and specifically that bill of materials. So if one of these large manufacturers say, here's the different encapsulant I'm using, here's the back sheets, here's the cells, et cetera, it's been up to like a 20 BOM or 20 different bill of material combination project. And then, some of that data for the top performers gets put into the scorecard. Other data where, they submitted BOMs that didn't do as well, and we've certainly seen where, a small change in material can impact performance. Those aren't in the scorecard, but we have access to all of those reports. And I should say the downstream has access to all of those reports when signing up to be a PVEL downstream partner. They can access that data and know, what's going on behind the scenes and get the full picture, where the scorecard is just kind of the tip of the iceberg to show, here's some of our data, and here's what you can learn when you sign up for access to the full picture.
Okay. Why should solar developers, project developers, asset owners, and other solar professionals dive deeper into module reliability?
Well, it's something I'm clearly passionate about. That's not the reason, but I could talk about the reasons for quite some time. So, I think the main reason is because lots of money is being invested in these sites, whether, it's a homeowner investing money for something that they put on the rooftop, and that could be a big purchase to them, or a C&I company trying to offset some of their energy by putting modules on their commercial rooftop, or, on the extreme, utility scale sites, it's hundreds of millions of dollars being invested. Everyone's expecting that the modules perform as advertised and as expected. And we've seen lots of field cases. One of PVEL's services is working in the field and helping to diagnose underperformance issues. We've seen lots of issues. Now, I don't want to be a naysayer. I believe strongly in the solar industry, and I think solar is the future. And, I don't want to say every module installed is a ticking time bomb, so to speak. But, in some cases, there are field issues. And as you said, you're doing this webinar on fires. These are things that can happen. And if you just read the manufacturer's data sheets and their sales presentations, it looks like everything's fine. But we provide this third party glimpse and third party insight into the module performance. And I think anyone investing in module technology should consult this data when making their purchasing decisions.
You know, one of the best known summaries of module quality is the Tier 1 list published by Bloomberg. What is the relationship between the Tier 1 list and the scorecard?
Yeah, so the Tier 1 list is actually, you know, it's kind of a misnomer. It's not about module quality. It's about bankability, loosely. So basically, to be on the Tier 1 list, manufacturers have to submit data to Bloomberg NEF to show that 6 different banks invested in their projects using their modules with non-recourse financing, and each project has to be 1.5 megawatts or larger. It doesn't talk about the, you know, financial fitness, if you will, or the financial stability of manufacturers. It really relies, if those 6 banks did their jobs, then other banks are going to invest in that manufacturer's technology. So it doesn't look at, you know, third-party audits. It doesn't use reliability data, et cetera. It's really, did 6 banks invest in this? And if they did, then maybe you would consider investing in them as well. So we have a partnership with Bloomberg NEF where on the Tier 1 list, there's a little asterisk beside the manufacturers who do PVEL PQP testing. And it was a way to make the Tier 1 list a little bit more focused on module quality and reliability. So if you look at the Tier 1 list and you see that asterisk, that means that PVEL has test reports on that manufacturer's products that are relatively recent. They would have had to do the factory witness for the PQP within the last 18 months to get that.
Okay, cool. That explains a lot. And yeah, I think it's poorly understood in the industry exactly what Tier 1 means. It is definitely a stamp of approval, but it doesn't necessarily tell you a lot about the quality of the product then, does it?
No, not at all. I mean, we talk to lots of people in the downstream, and they say, oh, I don't need PVEL's testing. I buy Tier 1. And it takes some time to try to show them why that's perhaps not the best strategy. You know, there's other strategies where, well, it comes with a 25 or 30-year warranty, I'm fine. And, you know, we highlight in the scorecard why why warranties cannot be relied upon as much as some people think they can. Or it was tested, it's certified, I'm okay. Again, in the scorecard, we highlight why certification testing doesn't go to enough. On the Tier 1 topic, we do have a great case study from Heliolytics, who do thermal flyovers of module sites. And basically, they can see module defects based on hotspots and other issues. And they showed basically a bar chart showing which module manufacturers have the most of this specific defect and which of those are Tier 1 and which aren't. And of the worst offenders, the top 10, 4 of those manufacturers are Tier 1. So it just goes to show that, you know, Tier 1 does not necessarily equal quality or reliability. You really have to dig deeper.
Indeed. So well, let's dive into this in a little greater depth. Describe for us the PQP, the Product Qualification Program.
Yeah, so it's basically, you know, doing that. The whole program is not just a test plan. There are certainly other test plans in the industry. But we have this program where we provide data to the downstream. The downstream requests the manufacturers for for that data, for that testing. You know, it includes a factory witness. We have manufacturers who say, oh, I'll just ship you some samples. You don't need to factory witness. Well, it's not called a PQP if we don't do the factory witness. So, you know, it's providing data to the downstream. We have a portal where they can log in and see those reports. And another key aspect is that we evolve it. Every year we add new tests or new characterizations, you know, based on our conversations with research institutes and manufacturers and the downstream developers, you know, asking what are they worried about. They were pushing us for last year on backsheet cracks. They were really concerned about that. There's gigawatts of modules in the field with backsheet cracks right now. So we developed our backsheet durability sequence, and last year we added it to the PQP. So it's really getting that feedback from the industry and seeing what do they need to de-risk their purchases, and that's what goes into the PQP, as opposed to we're just doing certification testing ×2 or ×3 duration, and we provide the reports, and that's that. You know, that's what other labs do. We look far more holistically at what does the industry actually need to feel comfortable making the purchases that they are.
Yeah, you know, we have 13 gigawatts approximately of solar being installed every year in the United States alone, and many times that, of course, globally, and that equates to millions and millions of solar panels. And so I guess that is something I'm curious about. I understand you're basically mimicking field conditions by doing some accelerated aging testing, you know, cycling through various temperature regimes or moisture regimes.
Yeah.
In an accelerated fashion. Is there a correlation between that testing and then what we see for actual long-term field performance?
Yeah, certainly, and there's lots of research that goes behind the test durations we've chosen, and we work with the industry to determine, you know, what tests are necessary. So we're really, you know, trying to tie what we see in the field for failures with what's happening in the field. So for example, you know, I talked earlier about damp heat 2000. Historically we were doing damp heat 3000 testing, and even before that we've seen people pushing that to damp heat 4000 and damp heat 5000. But what we saw is that the failures that were happening after damp heat 3000 were not happening in the field. And so what you had is module manufacturers, and even deeper than that, the component manufacturers designing their material to pass a test rather than to pass the field performance. And, you know, in some cases they're over-engineering it to pass a test where those failures weren't actually happening in the field. So we work with our industry partners to ensure that the tests that we're doing are representative. You know, we don't want to under-test, and we certainly don't want to over-test. And that's why we're tweaking the PQP every year, making sure that, you know, we're in the sweet spot, getting the data that the industry needs while not providing, you know, erroneous data or data that does not tie in well with field failures.
When I think of long-term field testing, I think of NREL, the National Renewable Energy Laboratory. Do you have collaborations at all with them?
Yeah, certainly. I know a number of their researchers. You know, in fact, one emailed me on Friday asking me to put together a letter on some of the issues that we're seeing in one of our tests. She wanted that to be tacked on to a report that they're releasing about this issue. And so, yeah, we're in contact with them. Another strong body in module and cell research is the University of New South Wales, down in Australia. and we talk to them quite a bit. There's also research institutes in Europe that we speak to. You know, they love that they get access to our data anonymously so that they can see the trends, and it helps them with their research. And, you know, their interpretation of our data helps us with our understanding. So we've got some great partnerships throughout the industry.
So I understand that it's free for downstream, right? For basically the end users of the program, like ourselves, installers, developers.
Yeah.
What do manufacturers pay besides presumably donating some product? Are there other fees that the manufacturers pay to participate?
Yeah. So the manufacturers pay for the testing. You know, it depends on how many bill of materials they're testing, how many module types. You can appreciate that, you know, sticking a module in a chamber for 2,000 hours, that's 84 days at 85% humidity and 85 degrees. There's definitely costs related to that. And it's the manufacturers that cover that expense. And so they pay knowing that, you know, it helps unlock business for them by providing these third-party reports to the downstream and by participating in the scorecard. So it's just like them paying for, you know, their standard UL or IEC certification. The PVEL PQP is another business expense for them, and they understand that the industry needs this data.
Great. You mentioned backsheet failure, and I'm just looking at one of the tables here on different failure modes. There's glass breakage, there's unsealing of the junction box, which is a little box on the back of the module where the wires come out of the module. There's PID, there's diode failure, there's bus bar corrosion, and delamination. Of all of these things, what if you're a solar developer, what are you losing sleep about? Do you see some points of failure being more of a problem than others, or is it just across the board?
Interesting question. I would say it's across the board. I think, you know, if I was buying modules, I guess it depends on what I'm developing. But if I was doing, say, rooftop development, I'd be quite concerned at safety-related failures. You know, we've seen in our testing in the last 18 months that 1 in 5 module manufacturers have junction box related failures. And, you know, as you said, it's just a box on the back of the module where the wires come out. But it's also operating at, in most cases, 1500 volts DC. And if there's a failure there that leads to an electrical arcing, that can certainly start a fire. And that's what I would be concerned about. If I was a banker, or, you know, putting tens or hundreds of millions of dollars on the line, you know, out in the middle of a field, maybe I'm less concerned about a safety risk, even though of course that would be concerning. But, you know, the degradation of modules and having a module suffer something like PID on my site that could lower the output by 10% or more, you know, that has real implications to the profitability of my project. So I would probably be losing sleep about module degradation, perhaps more so than safety failures. So, you know, I guess that was a long-winded thing to say that all of it is not good, and it should be concerning. Although certainly there are ways to mitigate those risks, and that's what PVEL is providing to the industry.
Yeah, risk mitigation is front and center here, and you can do that on the front end. You can do it during construction by having high quality construction, high quality installers. And then you can do it post installation by doing regular O&M, and that's a growing field. We have an O&M division now at Continental, doing an annual checkup, for example, where you test, you know, for is all the wiring sound? Is all the insulation on the wiring sound? Are the modules performing the way they should be, and so forth and so on? You're much more likely to nip a problem in the bud if you do that annual maintenance. So that's a big take home
Yeah.
For anyone who's got a vested interest in the solar array, whether you're the owner or just the host. So what about trends? And I love this. I love the summary table that shows over the years how different manufacturers are performing. But we mentioned sorry, early on in the podcast, we mentioned that this technology is changing rapidly, and so the testing protocols are changing. But what are some trends you see over time, and how do we think about that?
Yeah, so we try to highlight in the scorecard for the 4 reliability tests that we highlight, the top performers of. We show what the results were for the 2020 scorecard data set and compare that to the results for the historical data set. And you can see in some cases the performance is getting better. For example, in thermal cycling, in some cases it's getting worse. So one of the trends we found was that our potential induced degradation, or PID, degradation this year, or power loss, was the median power loss for the 2020 data set was higher than it's been in the history of PVEL. So in the past 10 years, the median result was higher this year than before. Now, we're not seeing huge amounts of degradation, like 30% from PID, which we saw years ago. But the fact that that median degradation is increasing shows that the PID is not a solved issue. And when we talk to manufacturers and show them the reports and say, hey, you had a PID degradation of 5%, they're normally shocked. Like they think that the products they're manufacturing are PID resistant, and they're surprised to hear that's not the case. Some of the other trends, we still see a high percentage of failures. About 20% of the bills of material we tested had at least one failure. Also in the scorecard, we teamed up with DNV GL, who is a technical advisory company who is actually the owner of PVEL for a number of years. And then 2019, there was a module buyout, and we went, or not module buyout, a manufacturer a management buyout. There's the word. And we went independent. But anyway, DNV GL assessed our historical data, and they have a case study in the scorecard showing some of those trends and how thermal cycling, for example, has improved over the years and pretty much plateaued for the last couple of years, versus, say, damp heat, which those damp heat results have been getting worse over the last few years. So we really try to show how the historical data is changing within the scorecard.
Cool. Yeah, PID is not something that we hear a lot about, but maybe that's just the nature of the Illinois market being such a greenfield, and
perhaps.
And I have noticed that the manufacturers are saying on their sell sheets or cut sheets that their products are PID resistant, but the proof is in the pudding. So
yeah, and we certainly see that is the case for some manufacturers, and what the claims on their data sheet match what our test results show, but not for everyone. So having that third-party data is important.
So on screen now, I've got the historical scorecard page of the report open, and you can get the report just by going to PVEL.com, and there's a a little notification right at the top that'll ask you to download, and then you hand over your credentials and you'll get a free copy of the report. But what are we looking at here? This is I think this is a wonderful snapshot if you're curious about, the big picture. Who are the leaders of the pack, so to speak? And you have a qualification called top performers. Well, what is the top performer?
So yeah, the top performers historically, at least for the last 3 years, they were manufacturers where their models, on average, the model submitted for testing had less than 2% degradation after these extended reliability tests. And there's 4 tests that we highlight: the thermal cycling, damp heat, PID, and another test called the dynamic mechanical loading sequence, where is one of the things I talked about earlier. We dynamically load, like physically load the module with different pressure, and then put it through climate chamber testing to see if there's micro cracking. So the manufacturers that had a model type that had less than 2% degradation in one or more of those tests were listed in the scorecard as a top performer. So the page that you had up shows that the 2020 top performers and what their history is in the previous scorecards. So you could see, have they shown through scorecard and PQP testing long, consistent performance in reliability, or in some manufacturers they're new to the program, and it just shows, in the case of, let's say, Synergy California at the bottom there, this was their first time as a top performer. So we're just trying to show how long these different manufacturers have been published in the scorecards.
And just because somebody didn't score like in 2014, it could be that they just didn't participate in the program, right?
Yeah, certainly. Maybe they participated and they had poor results. Maybe they participated and they had good results, but for whatever reason, they didn't opt in to be in the scorecard. It is definitely up to them if they want to be listed or not, or maybe we didn't test them at all. So, we don't really publicly state what those are, but certainly to our downstream partners who have access to our list of reports and the data, they can get a better sense of what the history is for those different manufacturers.
Gotcha. And then there are some categories of failures. We talked a little bit about this, but you break failures into safety, visual inspection, and power degradation kind of categories, right?
Yeah.
And so let's just walk through all 3 of those. Safety means when it's installed on your roof or on your ground, right? Is there some potential safety hazard for the facility or the people working around the facility?
Yeah. So safety, we use the certification test. The main certification testing standard is IEC 61215. So within that, there's a test called wet leakage testing, and that's basically putting the module in a conductive solution, water that's had a higher level of conductivity than normal tap water, if you will. So we put the module in that. We can submerge the parts of the module that are meant to be submerged. The other parts get just wet with the solution, and then we put a high voltage on the module, and we try to see if there's any leakage current from the conductors, basically the parts of the module that should be electrically conducting, versus the parts that should be grounded, such as the frame. So there will be a trip if there's a leakage of current between the active conductors to the frame, and that would be considered a failure. So that's really the main safety test. And it shows, was there any breakdown in the module's electrical insulation during the course of these, extremely difficult or extremely rigorous stress tests. On the other hand, there's also visual inspection. And again, that uses the criteria in that IEC standard to see, were there bubbles in the encapsulant, or some yellowing or, degradation of the encapsulant. Basically, was there any major manufacturing defects? And we do a visual inspection throughout testing to see, how has the module changed. Sometimes we see burn marks or corrosion, things of that nature would be considered a visual failure. And then the last category is power degradation. And we don't assign a pass-fail threshold, but what we do is share the results with the manufacturers. And if they are, upset with the amount of degradation they see coming from PID testing or thermal cycling or some of these other tests, they can trigger a retest. So when we do the factory witness, we take additional spares as samples, and they can say, well, I'm not happy with that PID result. Let's do another round of that testing using the spares, and that would be considered a power degradation failure because they didn't accept the results. It's not up to PVEL to say, here's what is acceptable and here's what isn't. But if they don't accept the results, then we classify that as a failure. And in the test reports, we will document anytime there is a retest so that there's transparency with the downstream and they can see that was the case.
Great. And so as we wrap up here, let's talk about steps that installers, developers, and asset owners can take to mitigate revenue risk. And you give a nice synopsis of this on page 36 for anybody who's interested in looking at the report. What are the 5 steps to mitigate risk?
Yeah, so the first is conducting factory audits, where, mainly utility scale developers and banks will require these factory audits where a third party goes in and audits the facility and makes sure that they're manufacturing following best practices. So, I've been subjected to this when I was in module manufacturing, and it could be a couple engineers visiting the plant for a few days and basically doing a very deep level audit of the manufacturing processes, all the way from incoming inspection to operator training, et cetera, and making sure you're doing the job correctly. Number 2 would be reviewing PVEL's PQP reports and using our data to choose the bill of materials, and basically saying, understanding at a deeper level what materials are being used and which performed well, and specifying those, which really brings us to the third step, which is specifying those materials. So we provide that to the downstream in bill of material exhibits that can be added to a purchasing contract to say, instead of buying a certain module type from a manufacturer, you're buying a specific bill of material. You're not allowing the manufacturer to just change out the cells. We show in the scorecard how changing cells can result in different amounts of degradation. Basically, you're buying a specific bill of material. Then to go with specifying the bill of material, confirming that product quality during production is important. So for large scale developers, they have the third party witnesses happen during production. So they want to make sure that the bill of material they specify is actually what's being produced. And then they're also looking at, any audit findings were addressed, and they're doing open box audits and making sure that the modules being produced are of the highest quality, or at least the quality that they're expecting and that they specified. Along with with that step, we also do batch testing to make sure, at our lab, we do flash testing and also, reliability testing of modules that were destined for the specific project. They get rerouted to us, and we can provide that data to show manufacturing consistency, which, we work with. Some of these projects are huge. It's 500 megawatts, if you will. They're being produced over months, and the developers want to understand how that performance is, how the consistency is for reliability and performance, and that's what our batch testing is. And finally, verifying the performance after installation. So PVEL offers different field services, as I was mentioning earlier. Two of the most popular are capacity testing, where we'll come with our lab equipment and verify that the site is performing as expected using our tools for analyzing that. And the other one is field EL, or electroluminescence, which is basically an X-ray of the modules, and you can see if there's any micro cracking or inactive areas, what have you. And that's becoming more and more important for baseline health of the site. And then if you're, I'm not sure about extreme weather in Illinois, but certainly south of there's lots of hailstorms and tornadoes and such that are wreaking havoc on some sites. And with baseline EL, you can show the insurance company, here's my evidence of how the site was built, and the module quality from a micro cracking and cell cracking perspective. And anything worse than that becomes an insurance claim. So I know that was a lot to take in, but certainly we spell it all out in the scorecard, and we're here. Some of those services are complementary, and I will just add that even if you're just a small installer, it's probably not feasible to send a third party into the factory. You're not making module purchases that are that large to justify that expense. The data is still available to everyone in the industry, and we don't discriminate with who gets access to the PQP data. If you're a module purchaser or a downstream module stakeholder, you can access that data and inform yourself when making purchasing decisions.
Wonderful. Well, we're almost out of time, Tristan. Is there anything else you'd like our listeners to know about PVEL or your services?
I think we pretty much covered it. We detail it on our website, pvel.com. You can get in touch with me there, or info@pvel.com. If it's a module inquiry, that will get routed to my inbox. And, we're here to help. I guess one thing that I'll say is that a lot of what we do is complementary. We get questions from the downstream all the time. Can be a confusing industry, and whether they're dealing with site underperformance issues or procurement questions, or they saw some report and they have questions, our lines are open, and we love talking to the downstream, and we love supporting the downstream. So don't feel like, you might have worked with other consultants agencies, and as soon as you ask them a question, the tab starts running for how much you owe them. That's not how PVEL works. If you have any sort of questions about solar, please contact us. And I guess I should also mention, we do offer PQPs for inverters, and we've published an inverter scorecard, as well as energy storage, which is, as you know, becoming huge. And there's lots of risks for, inverter technology and energy storage technology. And so we're offering PQPs for those as well. And we encourage you to review those reports and become educated on which products are performing well and which might not be.
Great. Well, that gives us 2 more episodes at least to do with PVEL. So let's continue that conversation about inverters and battery storage systems.
Yeah,
Folks, we're out of time, but that was the 2020 Solar Module Reliability Scorecard by PVEL. And I want to thank my guest, Tristan Erion-Lorico. Please do give us a thumbs up and subscribe to our YouTube channel. Tell your friends about SolarWorks for Illinois. And most of all, let's grow solar. I'm Tim Montague, your host. Have a great day.